Brian Cross, Associate Professor of Biology at Tulsa Community College, and your host for this special COVID-19 super pandemic edition of Wide World of Dissection. Tonight we have a special treat in store for you, Loligo vulgaris, the common squid. No, that doesn't mean we're going to be serving you all fried calamari. That would violate social distancing and quarantine rules, now wouldn't it? No, the nourishment we have in store for you this evening goes much deeper and lasts much longer. That is food for the hungry mind. For I think you'll find in this cephalopod mollusk ample portions of both bizarre behavior and fascinating anatomy, enough to satisfy even the most ravenous appetite for knowledge. More than a simple appetizer, the squid is a full meal for the intellectually curious to devour.
For centuries, the squid has stalked our collective imagination, from the mighty kraken of Norse mythology to the nemesis of Captain Nemo in Jules Verne's 20,000 Leagues Under the Sea, to the melancholy Squidward, co-worker of SpongeBob SquarePants. The squid has fueled our imaginations and haunted our dreams. The inspiration for much of this interest has no doubt been the giant squid, Architeuthis dux, a species that is widely distributed in the oceans of the world and can reach a length of more than 40 feet if you include the long tentacles. Here you see a specimen doing sit-ups with one of its trainers. And here you see two Norwegian children engaging in that easiest of all winter sports, the terrestrial giant squid sled race. For millennia, these creatures were the stuff of myth and legend. Sailors told stories of giant tentacled sea monsters, but these stories carried few details about the biology of the creatures, and in any event, respectable scientists considered them to be fiction. We knew little about the giant squid, but that it was very dangerous and could be defeated only with the help of pointy sticks and hatchets. These gentlemen went to sea prepared with both a hatchet and a stick, as did these fellows, and this young man at least had a hatchet. But this hapless fellow left port with neither pointy stick nor hatchet, with predictable results. It was not until the latter half of the 19th century that several specimens were recovered from the shores of northern Europe and North America. Only then did science take note and admit to the existence of such creatures. And it was only in the 21st century that anyone was able to capture live video of the giant squid in action. Today we will be looking at a cousin of Architeuthis dux, a smaller species, but one that has all the same basic anatomy, behavior, and abilities. So prepare yourself for a fantastic voyage into one of the most complex and sophisticated creatures that evolution has ever produced, the squid. Okay, so here we have an example of Loligo vulgaris, the common squid. There is a general zoological principle that states the more difficult it is to find the butt of an animal, the more interesting that animal is. And by that standard, the squid is a very interesting animal indeed. For when you first look at it, on first impression, it's hard to tell what's up, what's down, what's the front, what's the back, where's the mouth, where's the butt. And so we want to start off here by identifying the cardinal direction points. So over here on the left, we have the pointy end, that's the dorsal surface. So that's the dorsal side. Over here where the tentacles are and the arms, that is the ventral side. So dorsal and ventral. Now this surface that is looking up at you is the anterior surface, and you can identify the anterior surface by the presence of the eyes on the left and right sides. Right, the eyes are very complex. These are well-developed image-forming eyes. They're comparable to our eyes. In some ways they are better than our eyes, superior to our eyes, because they do not have a blind spot as our eyes do. Alright, so over here we have a squid that's positioned with the posterior surface up, so that you can get a look at that surface. So this is the posterior surface here. Over here we have the anterior surface, and here we have the posterior surface. Now, we identified the anterior surface by the eyes. The posterior surface will identify by this structure, the siphon. One of the cool things about squid and other cephalopod mollusks is that they move by jet propulsion. So this squid can pull water up into its mantle cavity, and then shoot that water out through the siphon, and the backward force of that siphon pushes the squid forward. It can also here move the siphon in different directions in order to steer itself through the water with that dorsal edge leading. Now in lecture you learned that mollusks have a three-part body plan. The three parts of the mollusk are the head-foot, the mantle, and the central visceral mass. As we look at this squid, you can see the head-foot over here on the right. All of the tentacles and the arms, as well as this portion that has the complex image-forming eyes, all of this is the head-foot of the squid. It is the portion that is specialized for locomotion, for prey capture, for consumption. The mouth will be located, as we'll see in a second, amidst all these arms. So this is the head-foot portion. Now over here at the other end we have the mantle. The mantle encloses both the mantle cavity with its gills, and it also encloses the central visceral mass. Now when you're eating calamari, you're actually eating the mantle. We pull out the visceral mass, we discard all the tentacles and all of that, and we just take the mantle and we slice it up. When we slice it up, it forms little rings, and then we throw those rings into batter, we deep fry them, and then we serve them up with a bit of lemon and some cocktail sauce. Deep fried goodness. Okay, so let's take a look now at some of the other external features of the squid's anatomy. You'll remember that on the left side here we have the dorsal surface. On the right side of your screen we have the ventral surface, and the ventral surface is where you'll find the appendages. We have two longer appendages known as tentacles that are used for the initial capture of prey, for snatching the prey up unawares. And then we have these 8 shorter appendages called arms, and those appendages are used for securing the prey, for holding it, positioning it as the prey is being ripped apart by the beak. Yes, squid do have beaks. In the middle of all of those arms at their mouth, their rending, tearing, ripping parts are formed as a beak composed of chitin. So it's very much, in some ways, like the beak of a hawk. It's not composed of the same material, but it's serving the same function. And so it's a great example of convergent evolution, these two different organisms having independently hit upon the same structure. Okay, two other features to note here are the lateral fins here at the dorsal end. The lateral fins can provide stability to the squid as it is shooting through the water. It may help with steering. It may also provide some thrust as well to the movement of those fins. Okay, so now we're going to take a look at the mouth part of the squid. The mouth is located right here in the middle of all of these arms. The squid has 8 arms. In the middle of those arms, we have the mouth with the beak used for tearing flesh. Behind the beak, there'll be a little toothed tongue called the radula. And in just a moment, we're going to pull this buccal mass out so you can get a better look at that beak. You'll also be able to see the esophagus, the first part of the digestive tract. Okay, so here we have a squid with all the arms and tentacles removed, and I'm just pulling out here the buccal mass, which contains the beak, the radula, the mouth. And you'll note as I pull it out here that it is still attached by the esophagus. So that white line right there, that is the esophagus. So that is heading into the main body of the squid. That is the digestive tract. So we have at the buccal mass here still attached to that esophagus. Now we're going to clip that esophagus. We're going to cut that esophagus so that we can free the buccal mass. So here we go. Snip. And we've freed the buccal mass. And now we're going to get all of the connective tissue and muscle away from the outside of that beak so that we can see it very clearly. And there it is, the chitinous beak of the squid. Here's a better view of a squid beak. This is not from the common squid. This is from the giant squid, Architeuthis dux. So you can tell from the look of it, filling up this gentleman's hand here, what a very fearsome creature this is, what a fearsome maw it has. This is not something that you want to encounter in the deep dark waters of the ocean even if you are Captain Nemo. Alright, so now it's time to solve that most perplexing of all zoological mysteries. Where is the butt of the squid? Now we know where the mouth is, so if we look amidst all these arms here, we can see the mouth with its beak right there. But that doesn't immediately tell us where the other end of the digestive tract should be. Is it at the pointy end, at the dorsal end? No, it's actually here. So we flip it over to the posterior surface, and we look right here, peeking out from inside the mantle cavity is the other end of the digestive tract. So there is the butt of the squid, there is the anus discharging fecal matter right above the siphon, and that should make good sense. We're going to discharge those waste products right above that flow of water so that all of that waste gets left behind us in our wake. Now, the way that it gets here to this location is that the digestive tract is U-shaped. So the digestive tract follows this pathway where it heads dorsally towards the pointy end, and then it loops around here and comes back to the ventral side, and it's going to discharge again right here above the siphon. Now, before we move on to the internal anatomy, there's one other aspect of the external anatomy I want to draw your attention to. We know at the ventral side here we have these two longer tentacles, and we also have these 8 arms. The tentacles are used for snatching up the prey, and then the 8 arms are used for holding on to the prey and manipulating it as it's being consumed. These 8 arms and the tentacles have these little suckers on them. These suckers have a chitinous ring with teeth, so it can be very unpleasant to have them grab hold of you, and each one of those little suckers is operated independently. And with this individual, which is a female, these little suckers go all the way to the very end of all 8 arms. So all 8 arms have suckers all the way to the very end. With this individual, you have a different situation. So you have most of the arms with suckers all the way to the end, 7 out of the 8. But this last one, the 8th arm, is called the hectocotylus. And the hectocotylus has these little ridges at the end, and those ridges are used for picking up the spermatophore, a packet of sperm, and transferring it over to the mantle cavity of the female. So that's a bit difficult to see there. So here's a diagram of a hectocotylus from another species, but the structure looks very much the same. We've got ridges towards the distal end, suckers towards the proximal end, and again, this arm is used to gently pick up the spermatophore and to transfer it over to the female's mantle cavity. So if you see a hectocotylus, it's a male. If you don't see the hectocotylus, it's a female. Now, in some cases, females will actually grab hold of the hectocotylus of the male and rip it off, and spermatophore and all, and abscond with it. And so if you see a squid running around with a severed hectocotylus with a spermatophore attached, that may be a female. Some might say that that's excessive commitment to a relationship, allowing your mate to rip your arm off and run away with it. But a squid have their own ways of doing things, and who am I to judge? Okay, so here we are going to look at the internal anatomy of a male squid. So we're just going to open up the mantle cavity, we'll pin him down, and we will cut off the posterior portion of the mantle to expose the mantle cavity and the central visceral mass. Cutting through that thick tissue. Okay, now we have everything exposed. Here we have 2 gills, the tenidia or the gills. Okay. And you can also see in this specimen here the bronchial heart. So this is a bronchial heart right here. Teasing out here, and there's another bronchial heart there. So you have a bronchial heart at the dorsal end of each gill, and those bronchial hearts are responsible for pumping blood into the gills for oxygenation. Now, in between the two bronchial hearts, you have the systemic heart. So in between the two, you have the systemic heart. So it's kind of like a multi-chambered heart, but in 3 different pieces here. Okay, so here we have the internal reproductive anatomy of the male. They're basically just 3 parts that you need to know. Down here at this end, we have the penis, right here. Okay, and then you have the spermatophoric gland and vas deferens, and then you have the testes. So we need to know those 3 structures. So the spermatophoric gland is going to produce the spermatophore, the material to make that packet of sperm, which will then be released through the penis. And then from there, that spermatophore will be picked up by the hectocotylus and passed off to the female. Okay, so now we're going to take a look at the digestive system. Right here we have the stomach and the cecum. So this is the stomach here, and then this is the cecum up here. So the cecum can be much larger, much larger. It can expand as it fills with food and become much thinner walled. This is a rather small specimen. It can be much larger. If we look here along the anterior side of the large digestive gland, well, there we see the pen, the reduced shell of the squid embedded within the mantle there. We'll look at that more closely later. But you can also see here the esophagus lying along the anterior side of the digestive gland. Okay. Now that digestive tract is going to loop around right where the stomach and the cecum are, and it's going to head back in the direction of the siphon. It's going to head ventrally, running along the posterior side of the digestive gland. And then it's going to discharge through the anus into the siphon. So we get rid of that waste product. Now you can also see here the ink sac, which is lying right along the intestines there. It can produce a cloud of ink that passes out through the anus, out through the siphon, and can be used to distract predators. Now these 2 straps of muscle here are the retractor muscles, and they are used to move the siphon. So they are the siphon retractor muscles. So they change the direction of the siphon, and thus the direction of that jet of water, and thus help the squid to steer through the water. Now here along the anterior side of the mantle cavity, embedded within the mantle really, we have the pen, the reduced shell of the squid. So some cephalopod mollusks have rather prominent shells, like the chambered nautilus. Some have no shell at all, like the octopus. But in the case of the squid, it is a reduced shell. We call it the pen. It's composed of chitin. Now we're going to pull this out. Okay, so we take the pen, and we could take the ink sac, which lies along the intestines and the rectum, discharges ink through the anus into the siphon, releasing a cloud of ink to startle predators. But here we're going to use the ink for a different purpose. We're going to write a message using the pen and the squid ink, and we are going to deliver a very important message here. Oh, the pen's falling apart on me. There we go. Excellent. Okay, so now we're going to open up a female squid and take a look at the internal anatomy of a female. So we're just going to remove the mantle from the posterior portion of the squid, posterior side. And now we're going to take a look at 2 structures in particular that I want you to know. We're going to zoom in here. And so the 2 structures that you need to know are the nidamental glands, which produce this material that coats the eggs and that makes them unpalatable. And then you also need to know the structure that produces the egg. So we have the ovary, which produces the eggs, and then the nidamental gland, along with some other glands like the accessory nidamental gland that produces material to coat the eggs. Those are the 2 structures that you need to know.
Well, that's it for our tour of the squid. I hope you've enjoyed your voyage into the marvelous world of the cephalopod mollusk. one of the most fascinating of all the creatures produced by untold ages of evolutionary change. Join us next week when we'll encounter another member of the phylum Mollusca, the bivalve mollusk. One that I think you will find is, while much less intelligent, no less fascinating than the cephalopod. Thanks for watching. Stay well.